Type 3. Kth success in nth trial. So this is the third type of repeated Bernoulli trial. Suppose a single Bernoulli trial has a probability of success P and probability of failure Q. What is the probability that the fifth success occurs in the eighth trial? To obtain the fifth success in the eighth trial, the first 7 trials must result in exactly 4 successes, and the 8th trial must result in success. As these are independent, the probability of the 5th success in the 8th trial is going to be the probability of 4 successes in 7 trials and, which means multiply, success in the 8th trial. So to work this out, we would use our formula from our formula book, which says n choose or times p to the power of or, p being the probability of success, times q to the power of n minus or, q being the probability of failure. So 4 successes in 7 trials, the n is going to be 7, and the or is going to be 4. So we're going to have 7 choose 4 times p, which is the probability of success, to the power of or, which again is 4, times q, which is the probability of failure, to the power of n minus or. So that's 7 minus 4, which is 3. And that's multiplied by success in the 8th trial, which is just going to be p, which stands for the probability of success. And p to the power of 4 times p is p to the power of 5. So 4 successes in 7 trials and success in the 8th trial can be represented by 7 choose 4 times p to the power of 5, q to the power of 3. A fair die is thrown repeatedly. What is the probability that the third 6 occurs on the 8th throw? Give your answer correct to 3 decimal places. We start by considering an individual trial, throwing a die. Success is getting a 6, while failure is not getting a 6. So success, which is getting a 6, is going to be p equals 1 over 6. Remember, p stands for success. And failure is not getting a 6, which is going to be q equals 5 over 6, because there are 5 ways that you can fail. 1, 2, 3, 4, and 5. And remember, q stands for failure. Then, the probability that the third success is in the 8th trial is going to be equal to the probability of 2 successes in 7 trials and success in the 8th trial. So again, we use our formula. So 2 successes in 7 trials is going to be represented by this. So where do we get our values from? Well, n is going to be 7 because there's 7 trials, or is going to be 2 because there's 2 successes. So n choose or becomes 7 choose 2. Then we have p to the power of or, and remember or is 2, so we've got p squared, times q to the power of n minus or. So n is 7 minus 2 leaves us with 5, so we get q to the power of 5. And means multiply, and success is just going to be p, and that's technically p to the power 1. And p squared times p to the power 1 is going to be p to the power 3, so we end up with 7 choose 2, p to the power 3, q to the power 5. At this point, we can then substitute p for 1 over 6, because remember success is 1 over 6, and q for 5 over 6, because failure is 5 over 6. So we have 7 choose 2 times a 6th to the power 3 times 5 over 6 to the power 5, and we end up getting 0.039 to 3 decimal places.